students. I am Dr. G. Hima Bindu from the Department of Mechanical Engineering, and I'll be dealing with the subject robotics, and my today's topic will be problems on robotics based on the links, right? That is problems based on the links in the robotics. Coming to the first problem, as you can see on the screen, the question that is an LL robo has two links of variable length, which is assuming that the origin of the global coordinate system is started at joint 1. Determine the following: the coordinates of the end effector point if the variable link length are 3 meters and 5 meters, and also we need to determine the variable link length if the end effector is located at 3 and 5. You can see this figure. Right here we have two links, that is link 1, this is link 1, and this is link 2, and this is the joint 1, and this is the joint 2, right? From this figure we can see this is L1, this is L2, link 1 and link 2, where L1 is 3 meters and L2 is 5 meters, where the joint is, we have two joints J1 and J2, where at the joint 1 we have the coordinates at 0, 0, and at joint 2 we have x2 and y2. Now as per the given question, L1 is 3 meters and L2 is 5 meters. Now let us assume that the angle between the links and the horizontal axis are theta 1 and theta 2, right? The angle between the link and the horizontal axis is theta 1 and theta 2. So as per the coordinate systems, as per the coordinates of the end effector, this particular end effector, we have x1 and y1. We have x and y, right? As per the end effector coordinates x and y, we need to write down the equation, that is L1 cos theta plus L2 theta 1 plus theta 2, or y is equal to L1 sin theta 1 plus L2 sin of theta 1 plus theta 2. In this form, we will be writing x and y coordinates, right? Now, as we already know that theta 2 is equal to 0. That is, for simplicity, we are assuming theta 1 and theta 2 such that the end effector is fully extended, where theta 2 is equal to 0. Then the x will be written as x is equal to L1 plus L2 into cos theta 1, and y will be equal to L1 plus L2 into sin theta 1, right? Now, if we are considering theta 1 is equal to 0, then what happens? X is equal to, as we know, L1 and L2 is 3 and 5. 3 plus 5 into cos 0, which is nothing but 8 into 1, right? That is cos 0 is 1. Y is equal to 3 plus 5 into sin 0. Sin 0, cos 0 is equal to 1. And sin 0 is equal to 0. So here we have got 8 and y. So the coordinates at the end effector x comma y is equal to 8 comma 0. That is, the coordinates at the end effectors with respect to the meters, that is the for both links and aligned horizontally, is equal to 8 comma 0, right? Moving on to the problem 2, here we need to find the link lengths given the end effector coordinators. Now, moving on to the second determination, we need to find out the link length given for the end effector coordinates. So here, as we already know, x comma y is 3 and 5, and L1 and L2 is already known. Now, x is equal to L1 cos theta 1 plus L2 cos of theta 1 plus theta 2, and y is equal to L1 sin theta 1 plus L2 sin theta 1 plus theta 2. Now, with respect to links, here we are giving, with respect to the end effector and the links, we are writing it as L1 square plus L2 square is equal to 2L1 L2 cos theta 2, which is nothing but x square plus y square. Already we have x and y values. When we are substituting that here, we have got it as 34, right? L1 square plus L2 square is equal to 34, right? Now, this when we are considering taking theta is equal to 90 degrees, right? This when we are taking with respect to theta 2 is equal to 90 degrees and cos theta 2 is equal to 0. Then L1 square plus L2 already this we have got earlier, that is 34, and L1 is equal to, with this equation what we are writing, L1 is equal to root 34 minus L2 square. That is nothing but 3 square. What is L2 square? It is nothing. What is L1? L1 square. This is L1 square. What is L1 square? 3 square. Right? 3 square plus L2 square is equal to 34. That is 9 plus L2 square is equal to 34. Where L2 square is equal to 34 minus 9, which we are getting is as 25. And L2 is equal to root 25 is nothing but 5 meters. Right? L2 is 5 meters, which has been justified. Right? L1 is equal to 3 and L2 is equal to 5. That is when we are considering theta 2 with as 90 degrees and cos theta 2 is 0, we will be getting the links L1 and L2 as 3 and 5. These solutions provide the link length and positions based on the given coordinates, assuming about these particular angles. Right? Next, moving on to the second problem. That is, an RR robo has 2 links and a length of 1 meter. Assume that the origin of the global coordinate system is at J1, that is joint 1. Determine the coordinate of the end effector point if the joint rotation are 300 at both the joints. Determine joint rotations if the end effector is located at 1 and 0. Now here we have, this is the joint 1, this is the joint 2, right? This is the link 1, this is the link 2, and this is the end effector for and this is the link 3 with respect to the end effector, where at the end effector the coordinates are being given as 1 and 0, and L1 and L2 is nothing but 1. L1 is 1 meter and L2 is also 1 meter. L1 is equal to L2 is equal to 1 meter, where the angles theta is equal to 300 degrees and theta 1 and theta 2 is also equal to 300 degrees. Now these particular angles we need to convert it into radians. Right? These particular angles we need to convert it into radians. How will we convert it into radians? Into pi by 180. When we calculate the given angle with respect to pi by 180, we can convert it into radians. So here that we have done here. Theta 1 is equal to 300 degrees into pi by 180, which we are getting as 5 pi by 3 radians, and 300 into pi by 180, which we are getting it as 5 pi by 3 radians. That is again here theta 1 is equal to theta 2, which is 5 pi by 3 radians. Right? Now, for this particular constraint, for this particular end effector coordinates x and y, we will be writing the equation as x is equal to L1 cos theta 1. Here, x is equal to L1 cos theta 1 plus L2 cos of plus L2 cos of theta 1 plus theta 2. Right? In the same way, for y direction, L1 sin theta 1 plus L2 into sin of theta 1 plus theta 2. Now, what is theta 1 and theta 2? Theta 1 is equal to theta 2 is equal to 5 pi by 3 radians. So, this theta, if we are substituting in these equations, we are getting as x is equal to, and L1 and L2 also we know. L1 is equal to L2, which is equal to 1 meter, right? So we are substituting all these values in the equation. We have got x is equal to 1 into cos of 5 pi by 3 plus 1 into cos of 5 pi by 3 plus 5 pi by 3. Y is equal to 1 into sine 5 pi by 3 plus 1 into sine of 5 pi by 3 plus 5 pi by 3. Now, when we are simplifying this particular equation with respect to angles, right? That is, any particular robo can rotate in 360 degrees, right? When we are considering with respect to the angles, cos pi by 3 can be written as cos of 360 minus 60, which we are getting as cos minus 60. That is, cos 60's value is 1 by 3. Sin pi by 3, again here we are getting sin minus 60. That is nothing but minus root 3 by 2. That is, sine of 60 value is root 3 by 2. With expression minus, we are getting minus root 3 by 2. Now, when we consider 10 pi by 3, right, cos of 10 pi by 3. Now, what is the angle which we are getting? It is nothing but 720 degrees. That is 2 rotations, right? When it is taking 2 rotations, cos 10 pi by 3 is equal to cos of 720 minus 60, which is nothing but cos 660. That is, cos minus 60 is 1 by 2. And again, sine minus 60 is minus root 3 by 2. So, the coordinates, whatever we are getting, will be equal to x is equal to 1 into 1 by 2 plus 1 into 1 by 2, which is 1. That is, x value will be equal to 1 and y value will be equal to minus root 3. So, these are the values of x and y, which is nothing but 1 minus root 3. Now, when we consider, now we need to determine the joint rotation for this particular term, right? That is, x and y we have got as 1 and 0. The length is L1 and L2 is equal to 1 meter. Using the inverse kinematics, so this is what we have got. So we need to calculate here theta 2 is equal to cos minus pi minus 1 by 2, which is equal to 120 degrees. Or when we consider theta 2 is equal to 240 degrees, what we are getting, theta 2 is equal to 2 pi by 3. This is what we are getting. Now here we need to determine the joint rotation for the given end effector position. So what is given, x and y is nothing but 1, 0. L1, L2 is equal to 1 meter. We need to calculate the distance r for the origin to the end effector. That is, the distance r from the origin to the end effector is taken as x square plus y square, root of x square plus y square. X value is 1, y value is 0. So, the distance r from the origin of the end effector is 1. Now, calculate cos of theta 2. Cos theta 2 is nothing but x square plus y square minus L1 square minus L2 square by 2L1 L2, where we are getting cos theta 2 as minus 1 by 2. Right? Now, in the same way, theta 2 is equal, since we have taken theta 2 is equal to cos inverse minus 1 by 2, it is nothing but 120 degrees, or theta 2, when we are considering it as 240 degrees, it will be theta 2 is equal to 120 into pi by 180, which is 2 pi by 3. Now here, for this particular problem, we have calculated theta 2. Now we need to calculate theta 1, right? Theta 2 is already been calculated. What is theta 1? Now how will we calculate theta 1? Theta 1 is equal to tan inverse y by x, which minus tan inverse L2 sin theta 2 by L1 plus L2 cos of theta 2. Right? In the same way, theta 1 is equal to tan inverse 0 by 1 minus tan inverse 1 by 1 into sin of 2 pi by 3 by 1 plus 1 cos of 2 pi by 3. What will we get? Sin 2 pi by 3 is equal to, we have already got sin 2 pi by 3 is nothing but sin 120 degrees. So that is root 3 by 2. So in the same way, cos 2 pi by 3 is nothing but cos of 120 degrees, which is nothing but minus 1 by 2. So here theta 1 will be equal to tan inverse of 0 minus tan inverse root 3 by 2 by 1 minus 1 by 2, where we get theta 1 as, what is this tan inverse 0? It is 0 minus tan inverse root 3 by 2 is tan inverse root 3 by 2 by 1 by 2. What is 1 minus 1 by 2? It is 1 by 2. Right? So here theta 1 will be equal to 0 minus tan inverse root 3. Right? That is tan inverse root 3 is nothing but minus 60 degrees. Right? Theta 1 tan inverse root 3 is nothing but minus 60 degrees. Tan minus root 3 is 60 degrees. So the joint whatever we have got, the joint angle are theta 1 is equal to 60 degrees, theta 2 is equal to 120 degrees, or with respect to the radius, it is theta 1 is equal to pi by 3 or theta 2 is equal to 2 pi by 3. Therefore, theta 1 is 60 degrees and theta 2 is equal to 120 degrees with respect to this particular problem. Right? Here what we have done with respect to the links L1 and L2 and with respect to the end coordinate systems 1 and 0, we have calculated theta 1 and theta 2 for this particular determined problem where we have got theta 1 is equal to 60 degrees and theta 2 is equal to 120 degrees. Clear? In the first problem, we have seen about the first problem is related with the basic link problem where we have just directly calculated the x and y values, right? And the second that is length 1 was 3 meters, length 2 was 5 meters, and we have calculated x and y values with respect to the equations. Right? This is the second problem in which again we have calculated the link lengths with respect to the end effector coordinates. Right? And in the second problem, we have calculated the angles with respect to theta 1 and theta 2. Right? So this is about. So these are the problems which are related to the robotic links and which are very important for your exam point of view. Right? So this is all for today. Signing off for today, Dr. G. Hima Bindu. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.